immediately. Session will begin within 2 minutes. The conference now proceeds to technical session 1, featuring the keynote address of this international conference. The theme for this keynote address is Dynamics of the Universe. I request Dr. Mahesh Bavre sir to kindly felicitate our chairperson for this technical session, Dr. Ram Kadam sir. Thank you, sir. I request Dr. Ram Kadam sir, chairman of this technical session, to kindly felicitate our today's resource person, Dr. Naneshwar Pawar sir. Thank you, sir. The distinguished resource person, Professor Naneshwar Pawar sir, is now requested to kindly deliver the keynote address.
Hello. Am I audible?
Yes, sir.
Thank you. Good afternoon to one and all. And welcome you again in the next session. Dear friends, basically I am working in two different topics. One is theory of relativity and cosmological models, that is directly related with the physics, and second with fractional differential equation, that is little bit related with the computer science. I have chosen the topic that is related with the physics. I have divided my talk in three different steps. First step is very small kind of basic information. Second step or second part is little bit informative, little bit related to the research, and the third part is purely devoted for the research. What kind of research we have done in our paper. Okay. When you will be bored, just tell me and raise your hands. Sir, please stop. I will stop there. Okay. Now door is closed. No one can go out. Okay. Dear friends, I am going to talk about the dynamics of the universe. Dynamics of the universe. Basically, when we think about the study of the universe, it is belongs to the physics as well as mathematics. But in particularly, astronomy, astrophysics, cosmology, these are the sub-branches of physics and mathematics. In terms of the cosmology, cosmology is a branch of science which studies the universe as a whole, containing all the galaxies, stars, neutrons, protons, quasars, everything. This cosmology words came from Greek history. Cosmos. Cosmos means universe, and logy means study of the universe. That's why we call it is a study of the cosmology. Actually, if we think about the understanding of the present day's universe, when it was evolved approximately 13.8 billion years ago. And when we talk about the human civilization is nearly about 5,000 years ago. Means it is one of the very oldest branch of science that human is thinking about the sky and stars in the sky like that. That is actually related with the cosmological part. Actually, very recently, from after the presentation of Einstein's general theory of relativity, actual research in terms of cosmology is going on. Means after 1915, when Einstein was presented the idea of the general theory of relativity, after that, actual research in cosmology was going on. If we talk about the cosmological models are nothing but the mathematical models which predict the prediction about the universe. What kind of universe will be there? What will happen? What kind of physics will be applied? Means just like as at the time of corona pandemic, you observe that there were some mathematical models. Mathematicians presented some mathematical models before the second corona wave, and accordingly that was happened. Means prediction with the help of mathematical technique. Those are predicted by mathematicians. Definitely maximum means predicted models and actual experimental evidences. They are agree with each other. Then that will be universally accepted. Einstein himself predicted theoretical observation together with cosmological models. Cosmological models are the nothing but in the language of mathematics we say that these are the mathematical models about the study of the universe. If we observe the ancient civilization, at that time basically Greeks, Mayans and Indians were presented different models of the universe. There are two kinds of models. One is geocentric models of the universe and another is heliocentric model of the universe. Before Christ, near about 300 years of before Christ, Aristotle, one of the Greek philosophers, who was presented the idea of the universe, and he was presented the model of the universe which is in terms of geocentric model. Geocentric means what? Earth is at center and all the planets together with sun and moon are moving around the earth. Earth is moving in its own axis of rotation. That was the model presented by the Aristotle. Aristotle was a philosopher, politician. He has wrote some books, some ideas about the politics, about the psychology, about the philosophy, about the astronomy. He has written so many books on different aspects of philosophical to scientific. But basically, Aristotle was one of the philosophers. He was not the astronomer, he was not the mathematician, physicist. After the Aristotle, Aryabhatta, Indian mathematician as well as astronomer. At the time of 500 years after Christ, Aryabhatta presented the idea of the universe that is again in line with the Aristotle. Means that is the geocentric model of the universe. But having some different ideas, Ptolemy, Aryabhatta again follow the idea of Aristotle. But Aristotle's ideas were wrong. After when Copernicus was the first, he was presented the new model that is called as the heliocentric model of the universe. Heliocentric model of the universe means sun is at the center, all the planets together with the earth, they are moving around the sun. That was the idea. Basically, before the Copernicus, it was Aristotle as well as Aryabhatta, they were assumed that the universe is in terms of circular form. Means universe is, because if we observe the idea of Galileo or now Kepler, they have proved that all the planets moving in an elliptical orbit. All the universe is in terms of the spherical shape. But before that, there were assumption that the universe is in terms of circular. With this assumption, after Copernicus presented his idea at the time of 15th century. After 1529, at that time he was presented the idea of heliocentric. No one can believe on that because before that, more than near about 2000 years, everyone believes on the geocentric model. Copernicus presented the heliocentric model, and just after the Copernicus, under the observation by using some telescope, Galileo confirms his ideas about the heliocentric model. And Galileo presented some observational evidences for the support of his assumption of heliocentric model. And after the Galileo, that is confirmed that our universe presenting the heliocentric model of the universe. Because of his idea, church was not agreed with the idea of Galileo. That's why church punished him. And he was under the arrest in his house at the time of his last. Only because of his idea about in opposition with the church idea. Because all the philosophers agreed with the idea of geocentric model. Earth is at center and all the planets moving around the earth. This is the idea actual behind the two models, and now all of us are agreed with the heliocentric model with observational evidences of Galileo. We know that Galileo, then Kepler, Einstein, Newton, everyone follows the idea of heliocentric model of the universe. Again, despite of the significant progress in the study of the universe, again there are some mysteries are there. Now many of you listen about the dark energy and dark matter, Big Bang. Again, how is the Big Bang? What happened at the time of Big Bang? These are some mysteries are there. What kind of nature of dark matter and dark energy? Again, what happened in the first moment of Big Bang? Again, after Big Bang, before Big Bang, what was happened? Because there are two kinds of thoughts are there. One, philosophers agree that the universe is not a created, created not by using the scientific process. It is created by God. It was, it is, now it is, and it will be as it is. That is a concept of philosopher or some mythological thoughts. Means in each religion having their different thoughts about the universe also. And they always predict that Allah, God, Yesu, they have created the universe, and there is, now it is and it will be as it is. Means that is called as a static universe. No change is there. That is as it is. But the scientific evidences are there. Under the telescope, Hubble telescope, in after the presentation of Einstein's general theory of relativity, 1929, Hubble has discovered that our universe is expanding with rapid speed of expansion. Universe is expanding, it means that universe is dynamic. It is not a static. Universe is expanded with some speed, and it is observed under the telescope with some experimental evidences. means all the researchers agree with that. It means that universe is expanding, just like as a balloon. We put some air in the balloon, that will be expand, and after its capacity it will be burst. That will be finished. Just like that. The idea of Big Bang is, at the time of Big Bang, the universe was created. There are two kinds of situations there. One is expanding universe is there, another is contracting universe is there. Contraction means we put a mass together and compresses completely and it will create in a single mass point. After single mass point, that will again burst. Or just like as balloon, it will be expand and it will be again burst. That situation we call it as a Big Bang. Means at the initial stage. Big Bang is there, it means there is a birth of the universe, there is a end of the universe, now the present age of the universe. These kind of concepts are there. Researcher again Stephen Hawking presented the idea of history of time. History of time, and also he believes that the creation of universe is just the scientific process. There is no role of God in the creation of the universe. He has wrote in his book, and he strongly agreed that the creation of universe is one of the cyclic process of the scientific process of cycle. Means after some year it will be created, it will be destroyed, like that. Then what happened at the time of Big Bang? Now human being always curiosity about the universe. In the Switzerland, last year we attended one conference. I was given one talk in that international conference also. At that time we visited that CERN lab. Many of you listen about that. CERN lab is specially designed and developed under below the earth, some 300 kilometers below the earth. They have created one lab and they have set up one experiment of hydrogen collider, and they want to create the situation at the time of Big Bang. That kind of boosting. Many of you listened that at that time there were some news are there, maybe our earth will destroy because of black hole and like that. But that is happened because Einstein also shown that there is a black hole in the universe. When the situation will be created by that experiment, they will also create some black holes, but for some fractions of second. That's why our earth will not destroy. They will create black hole, they will create the situation for fractions of second. Okay, these are some mysteries about the universe. Again, the ultimate fate of the universe is still uncertain. What kind of fates are there? Universe is expanding. Is that universe is forever expanding, or after some time it will be collapse? There is a question mark. No one knows about that. Second thing, what will dark energy influence its future? Many students are sitting over there. See that I am talking about dark energy and dark matter. Many of you don't know about that. See that our universe containing 68% part of the universe is by dark energy. 25% part of the universe is occupied by the dark matter, and we human beings only reach that, we call it as a bionic matter. We reach up to the 5%. Means those things we know it about the universe, only that is within the 5%. 95% part of the universe is not visible, not under the observation of human beings. That's why that part, we don't know anything about that. We give the name that is called as the dark energy and dark matter. Physically, mathematically, we verified, we put some test, we apply some mathematical formulas, and to check that why we call it as a dark energy and how we call it as a dark energy. That is a different concept. How we can predict that part is a dark energy, because many of you maybe have the question that if we don't know anything about that, then how we can say that that part is a dark energy, that part is a dark matter. Mathematically we have verified it. Just like that, in 1615, Einstein introduced the idea of gravitational waves. Many of you listen about that gravitational, yes? And just 10 years before, You listen about that, the detection of gravitational waves, not particle detection of gravitational waves. What is that? Einstein predicted the gravitational waves mathematically, existence of gravitational waves mathematically in 1950. Okay, and experimentally, many labs were set up in the world. Some crores of $1 billion were put many countries for the detection of gravitational waves. LIGO lab. Many of you know about the name LIGO. One lab nowadays that work of LIGO lab is going in our Maharashtra, in our Marathwada region near the Ahmedabad. That lab is set up by American government in collaboration with Indian government. LIGO, laser interferometer gravitational observatories. That was first lab developed in America, and that lab where detected that gravitational wave in 2015. That 2015, that date also I was mentioned. You can see it. I think in September 2015, gravitational waves were detected. What is meant by the gravitational waves? Gravitational waves are nothing but the ripples of curved space-time. जसं काय होतं? आपला कपडा जो आहे ना, प्लेन कपडा, कपड्याला जशा घड्या पडतात, बुड्या पडतात, म्हणजे युनिवर्स इज अ कर्व्ड स्पेस टाइम as far as the Einstein observations are there. And gravitational waves, initially no one can believe on the gravitational waves, concept of gravitational waves. But कपडा काही कायम प्लेन राहत नाही. तसं just like as universe having some ripples म्हणजे त्याचे काही बुड्या पडणे, घडी पडणे, त्या पद्धतीचं. मग त्या पद्धतीचे रिपल्स असतात म्हणजे that will create some waves. And that waves are created only because of the gravitational effect. And that gravitational effect we call as the gravitational waves. And detection of gravitational waves are nothing but the test to confirm the idea of general theory of relativity presented by Einstein. Before going to talk about the Einstein and Newton and general relativity and all those things, what is the mathematics behind that? That is a part of physics. Now I am talking about what is the role of mathematics. Many of the students know that till today, which kind of geometry we have used in our daily purposes? That is, student ला माहिती आहे ना आपण कोणत्या geometry वापरतो, x axis, y axis, z axis, flat surface, distance between the 2 points, like that. That geometry we call it as a Euclidean geometry. See that Euclid present the Euclidean geometry before 300 years of Christ. Before 300. And after Euclid, near about 1950s, Riemann was the first who has changed the idea of geometry. Means more than 2000 years, no one can think about the revision or modification of Euclidean geometry. So what kind of powerful concept he has presented. See that. Nowadays also. It does not mean that Riemannian geometry come into the picture means it is completely free. Different concept, different ideas behind the two geometries. Some ideas failed by Euclid in the study of the universe. That's why there is a new role of Riemannian geometry. Later on we will talk about the Riemannian geometry also. Euclidean geometry basically based on the ideas of parallel lines, right angles, as well as triangles, right angles, and basically Euclidean geometry based on the 5 postulates or 5 axioms. Parallel lines never meet with each other. Sum of angles of 3 angles of a triangle is exactly 180 degrees, like that. 5 postulates presented by Euclid, and with the help of Euclidean geometry, Newton's developed the Newtonian mechanics. He has used the complete idea of Euclidean geometry, fundamental, basic, classical physics, completely based on the geometry of Euclid. Okay. Newtonian mechanics. All of you familiar with the Newtonian mechanics? See that. Initially we talk about the two models of the universe, geocentric model as well as heliocentric model. Up to the Copernicus and Galileo. After Galileo, it is confirmed that our universe follows the heliocentric model. And based on the heliocentric model, Newton's given the exact scientific way to present the idea of the universe with the help of 3 laws of motion as well as universal law of gravitation. Before that, no one can present the idea of the gravitation. What is meant by the gravitation? As far as the Newtonian mechanics is concerned, gravitation is nothing but the force of attraction between the two massive bodies. Two massive bodies having a natural force of attraction. That is the idea behind the Newtonian mechanics. See that this is the formula, gravitational law. First three are the three laws of motion. Laws of inertia, force is equal to mass into acceleration, that is the second law of motion. Third is the every action there is equal and opposite reaction, that is the third law of motion. And universal law of gravitation having this formula, force is directly proportional to the square of the radial distance between them. Means force of attraction, the distance will be reduced, thus force of attraction will be increased. That is actually the concept of gravitation. Okay. After 1687, Newton presented his Principia. In his Principia, he presented the idea of the three laws of motion as well as universal law of gravitation. After Newton, more than 200 years, no one can again think about the revision of Newtonian mechanics. No one can dare actually. At that time, everyone, nowadays also, Newton was one of the genius. He was presented those ideas no one can deny. Okay. After 1617 to 1905, first Einstein was presented the idea of special relativity. Till that date, no any physicist, no any astronomer, astrophysicist, they denied the idea of Newtonian mechanics. Newtonian mechanics is completely based on the Euclidean geometry. Similarly, Einstein's theory of general relativity is based on the Riemannian geometry. Why I talk about the mathematical concept? Because see that both the physical genius, means those Newton as well as Einstein, they have presented the idea of the universe. They have presented complete laws. They have changed the idea of physics with the what kind of geometry? Newton used the Euclidean geometry, but Einstein denied that. Why? When Einstein presented the idea of special theory of relativity, at that time Einstein also used the Euclidean geometry. With the help of Euclidean geometry as well as some fundamental concept of Newtonian mechanics, he was presented the idea of special theory of relativity. And in the special theory of relativity, you already listened about that clock paradox is there, time dilation formula is there, as well as E equals to mc square, one of the outstanding and very famous equation presented by the Einstein in 1905. But Einstein himself thought that that theory is not self-sufficient to present the whole idea of the universe, because special relativity study or restricts its study only for the uniform translatory motion. Not it accommodates all kinds of motion as well as the concept of gravitation. That's why Einstein thinking about the revision of Newtonian mechanics. And when he was thinking about the revision of Newtonian mechanics, he thought that Euclidean geometry is not sufficient for the study of the universe, because the idea of Euclidean geometry is the idea of flat surface, flat geometry. When we talk about the distance between any 2 points, unless we take a straight line in between that, by using the distance formula, we will calculate the distance. That is the concept of Euclidean geometry. But when we talk about the large distances, for example, when we talk about I want to find out the distance from Nanded to Latur, straight away we can say that it is 130 kilometers nearby. Okay. किंवा असं इथून मुंबईचं distance किती आहे? Like that. हे distance आपण easily सांगू शकतो, but how we calculate that distances? With the help of Euclidean geometry. Euclidean geometry means straight line geometry. आपल्याकडे geometrical parameters काय आहेत बघा, पट्टी घेतो आपण. Straight line असते. Straight line ने distance count करतो. मग हे छोटे-छोटे distance बघा रस्ते बनवताना तुम्हाला दिसत असेल की they count all that distance with the help of some telescope. They try to cover up maximum straight distances, and then one by one they join with each other and they will decide the actual distance. That is the idea to count the distance. But when we talk about the very large distances, just like the distance between two galaxies, I am not talking about distance between the two planets. That is also very large. But if you talk about the distance of two galaxies, it is a distance of some light years, some crores of kilometers are. Then how to calculate that such kind of distances? Naturally, natural geometry of Euclid's will not applicable there. That's why Einstein want such kind of geometry that will naturally provide the geometrical concept for the study of the universe, because the idea of special relativity and general relativity is different. Einstein presented the special relativity with the concept of flat geometry. And Einstein in 1915, he was developed the general theory of relativity with the help of the concept of curved geometry. That is the difference between two theories. Because Einstein accommodated all those ideas that were not accommodated by the special relativity. Gravitational theory as well as all kinds of motion, everything Einstein wanted to accommodate in a single theory. That's why he was developed the general theory of relativity. And see that what is the coincidence. Naturally म्हणतो ना आपण एखादी गोष्ट काही नॅचरली जुळून येत असते तसं बघा. Just before the Einstein presented the idea of the universe in 1915, and just before the Einstein 1850, that great mathematician Riemann was there, and Riemann was developed the Riemannian geometry just before the 50 years of Einstein. And Einstein made one statement that if maybe Riemannian geometry were not there, I was not able to develop the general theory of relativity. And because of only development of Riemannian geometry, I was able and develop the general theory of relativity. And what is the coincidence? Just before the Einstein, Riemann came into the picture. म्हणजे पिक्चर म्हणण्यापेक्षा पृथ्वीवर आधी जन्माला आले 50 वर्ष. ते जर उलट झालं असतं तर म्हणून काय म्हणतात ना, नॅचरली मेनी थिंग्स हॅपन अकॉर्डिंगली ॲज पर द लॉ. तसंच लॉज ऑफ फिजिक्स, लॉज ऑफ नेचरच काही गोष्टीला सपोर्ट करते. म्हणून रेमनियन जिओमेट्री, रेमन आधी आले. Riemann was developed the Riemannian geometry. After that, Einstein developed the general theory of relativity, and from 1952 till today, whole world is doing their research of universe along the direction of Einstein general theory of relativity. And behind that, म्हणजे मूवीच्या मागे जसं डायरेक्टर असतो तसं behind the general theory of and Einstein theory, Riemann was there. Because of only Riemannian theory, tensor algebra. Many of you know about that. Tensor algebra was provided by the Riemann. Okay, and the idea of Riemannian geometry is curved geometry, and he was provided the fundamentals for the general theory of relativity. Just now I talk about that the work of Einstein. Einstein developed two theories: special relativity as well as general relativity. What are the main contribution of both the theories? First, E equals to mc square, given by the special relativity. Means Einstein was the first who was given the idea of energy equivalent to the matter, and matter is equivalent to energy. They are both directly proportional to each other. E is equals to mc square. Means mass creates energy, energy creates mass. Vice versa. That is the beauty of this equation, and because of this equation, that atom bomb were invented in the Second World War. Only because of this concept E equals to mc square. And second major contribution of general theory of relativity is that is a field equation of general relativity, including the gravitation also. In the special relativity, there is no gravitation law is there, gravitational force, or what is meant by gravitation, it was not accommodated. And if we observe the fundamental equation of universal law of gravitation by Newton and field equation of Einstein, basically, maybe, yeah, see that. This is the field equation of that G mu nu lambda G mu nu is equal to this equation, and that figure represents the idea of the gravitation. These mathematical tools provided by Riemann. This G, lambda are like this, all these fundamentals, tensors provided by Riemann, and it was systematically used by the Einstein in his differential equation. Basically, this is the second order non-linear differential equation in terms of tensors. Second order differential equation in terms of tensor which describe the gravitational field. And here the idea he has used as it is, just like as the Newton. When you observe the Newtonian equation, it is much. See that left side represent the, no, this is not the actual form of universal of gravitation. Actually, in the fundamental equation of Newton, that concept of gravitation they have included. Left side represent the geometry part here, and right side represent the matter part. If some geometry is there, definitely matter will be there. If matter is there, it has some geometry. That is again vice versa. Means that is a natural phenomena in the universe. Geometrical part left side and right side represent the energy momentum tensor, means matter content part is there. And in this equation, it accommodates the idea of the whole universe within one single equation. And in this figure you will see that असं बघा क्लाउड एक सरफेस दिसतोय, त्याच्यात एक बॉल टाइप मास क्रिएट केलेला आहे. त्या मास क्रिएट मुळे काय होतंय, that flat surface will become the curved surface. इथे कर्व्ड असं भोंगा तयार होतो ना. लहानपणी आपण लग्नाला मंडप असायचे, तुम्ही केलं का नाही मला माहित नाही, पण आम्ही गावात करायचो की मंडपात काय करायचं, थोडा खड्या टाकून पहा, दगड टाकून पहा, कामं नसायचे लहानपणी काय काय टाइमपास करण्याचं. ते खड्या छोट्या छोट्या टाकल्या तिथं असं छोटा छोटा भोंगा तयार. That is the natural concept of gravitation as far as the Einstein's concept. Newtonian concept is force of attraction between the two massive bodies. But as far as the Einstein, gravitation is nothing but it is a consequence of curved space-time, natural consequence. तो काही force of attraction नाही, काहीच नाही. म्हणजे कसं आहे, साधा concept आहे बघा. When more curved surface is there, जेवढा curved भोवता असेल तेवढा काय होईल, तेवढा शार्प दुसरा जो बाजूचा मासिव बॉडी ती घरंगळत खाली जाईल, तेवढा फास्ट खाली जाईल. म्हणजे जेवढी एक मोठी मासिव बॉडी टाकली तेवढा मोठा भोंगा तयार होईल, आणि त्याच्या आजूबाजूला तुम्ही छोटे कुठलेही मासेस फूट केले ते काय होईल, त्याच्याकडे नॅचरली घरंगळत जाणे म्हणजे उडले जाते. दॅट इज नथिंग बट द ग्रॅव्हिटेशन. दॅट इज द आयडिया ऑफ ग्रॅव्हिटेशन ॲज पर द आइन्स्टाईन इज कन्सर्न. आणि समजा याच्यापेक्षा दुसऱ्या अजून थोडा लांबच्या याच्यात आहे, तो त्याचं स्वतःचं ग्रॅव्हिटेशनल फील्ड तिथं कर्व्ड स्पेस तयार करेल. त्याच्या जवळपास गेलो म्हणजे our sun is so massive as compared to the earth and other planets. That's why near the sun very high intense gravitational field is there. That's why no one can go there because of high intense gravitational field near the sun, because of the concept of curved nature. Curvature is there, more curvature is there, more gravitation is there. That is the simple idea behind the gravitational force as far as the Einstein is concerned. Second thing, idea of Newton. Idea of Newton was the space and time are absolute. Absolute space and absolute time. Absolute space and absolute time म्हणजे काय? If time is separate, space is separate. They are separate entities. They are not related with each other. They work independent. But Einstein connected both of them in the special theory of relativity and called it as a space-time, not space and time. They are interconnected. Just now I talked about that after Newton, Einstein theory is one of the very highly successful theory of gravitation. It does not mean that Newtonian theory is completely failed. Newton's theory of gravitation is also highly successful, but it has some limitations. Newton's theory of gravitation is successful at the low point of scale. Locally it is successful, but globally, when we talk about the large distances, curved spaces, when we talk about the galaxies, at that time Newtonian mechanics is badly failed. And there is a role of Einstein theory of relativity. That's why in common people, ordinary people don't know much about the concept of Einstein relativity. They don't understand the concept of Einstein relativity because they are not familiar with the concept of galaxies and planets and all those things. They know only the many things about the Earth. And in the Earth, we always feel and we always satisfy the laws of Newtonian mechanics. In spite of highly success rate of Einstein theory of relativity. Again, it has some drawbacks. It has some problems. Just now I talked about that gravitational wave detected where many things are there. Einstein theory of relativity also having some drawbacks. After 100 years, many mathematicians, many physicists observe that there is some issues in the Einstein general theory of relativity, and there is a role of modified theories of gravity are there. What kind of drawbacks, what kind of lacunas are there in general theory of relativity? Because just now I talked about that to accommodate all ideas of motion as well as gravitation, Einstein developed the relativity, but always we know that we are the people from science, no any theory will be the complete theory. Day by day it has some problems, it will have some revisions, it will have some modifications. Just like that, Einstein theory having some modifications. Why? There are some drawbacks. First one is incomplete description of gravity. Many concepts of quantum mechanics are not integrated with the general theory of relativity. That is one of the big drawbacks in the general theory of relativity. That is not compatible with the concept of quantum field theory. First one. Second one, Einstein presented the idea of singularities. There is a singularity problem is there. Many of you listen about the black holes. Just now I talk about the Big Bang. At the time of Big Bang, that density as well as pressure will become infinite. Means all laws of physics will break down there. Means we can't predict anything at the time of Big Bang. That is called as the singularity problem. Big Bang as well as black hole. Black hole, you know that everything is absorbed, nothing is emitted. Near the Big Bang, black hole, everything is absorbed. Means again, the laws of physics will break down there. Means these two are the big issues in the general theory of relativity. How to avoid these two issues, that is not given by the Einstein. Next one, the concept of dark energy and dark matter. See, general theory of relativity actually explain, observe the expansion. Universe is expanding, but with the help of dark energy. And that dark energy till now not existed. Same thing is happened with the in terms of dark matter, because general relativity requires to explain the galactic rotation curve with the help of dark matter. But again, dark matter till now not directly experimentally detected. That are some basic and standard drawbacks of the Einstein general theory of relativity. That's why many mathematicians, physicists go for the modified theories of gravitation. Time सांगत चला. आता हा पार्ट कसा झाला, आपण मिडल मध्ये आलो आता. Just now I talk about that. I have divided my talk in 3 parts. Now we are in the middle of my talk. In the middle, there is little bit informative, little bit tending towards the research topic. Okay. Our research topic is we are working on different modified theories of gravity. My research students and me, we are working in the different alternative theories of gravitation because of some drawbacks of Einstein general theory of relativity. Some mathematicians has been developed some modified theories of gravity, just like as Varadkar theory, F of R theory of gravity, F of T theory of gravity. And what kind of modifications are there? See that Einstein developed the Einstein theory of relativity with the help of action principle. Many of you know the action principle of mathematics. With the help of that action principle, Einstein developed the geometrical idea of field equation of general relativity. That field equation modified by mathematician and developed the new theories. In F of R theory, they have modified the Ricci scalar. Ricci scalar means that R, capital R, they have modified this R function. In F of T, teleparallel gravity, that called as a teleparallel means replace that curvature, concept of curvature by the torsion. Torsion म्हणजे आता बघा, म्हणजे थिंकिंग आहे, लॉजिक आहे. No one can exactly know about the universe. Okay. जसं मी सुरुवातीला म्हटलं की no one can believe on the detection of gravitational waves. Gravitationचा concept काय होता की universe is curved, it's okay. But curved मध्ये कसं आहे, पडदा प्लेन आहे, प्लेन surface आहे. मग त्याच्यात रिपल्स असले काय होतं? Just like as waves, they are created by waves, means that is nothing but the gravitational waves. That ripples created only because of the gravitation. Now the new concept is torsion. आता theory मध्ये काय होतं? There are three kinds of theories are there. One is curvature theory, another is non-metricity tensors are there, and third part is by using the torsion scalar is there. Torsion. आता torsion चा concept काय? की युनिवर्स मध्ये असंही होऊ शकतं की प्लेन सरफेस किंवा एखादा पडदा हवेत उडल्यावर कसा होतो? असे एकमेकात गुंडाळला जातो, ट्विस्टिंग. सम ट्विस्ट विल बी देयर. मग युनिवर्स मध्ये असं ट्विस्टिंग असू शकतं. That concept of twist is nothing but the idea of torsion. By introducing the torsion, by using the mathematics, they have introduced the torsion for the study of the universe. That is called as the tele-parallel gravities. We call it as a f of t gravity. F of t gravity again. Einstein-Gauss-Bonnet theory, they have included higher order derivatives. See that, just now I talked about that. Einstein field equation of general relativity is the equation of second order partial differential equation. Means derivatives are up to only the second order. But Einstein-Gauss-Bonnet theory introduced the higher order derivatives in that theory. Like that, F of G theory is there, fractal cosmology is there, fractal geometry. You see that. New concept, torsion, non-metricity, curvature, these are the ideas or thinkings of mathematicians and physicists to predict about the new ideas about the universe. Fractal means fractal geometry. We know that the fractal geometry is again one of the concepts. Universe naturally behaves just like as a fractal kind of concept. Because the galaxy distribution is just like as a fractals. Fractal म्हणजे काय? कॉलीफ्लॉवरचं किंवा सूर्यफूल, सनफ्लॉवर, त्याचे टेक्निक बघा कसं असतं? फ्रॅक्टल इन नेचर. दे हॅव रिपीटेड सेम पॅटर्न आफ्टर सम टाइम, रिपीटेडली हॅव्हिंग द सेम पॅटर्न. तुम्ही सूर्यफूल बघा, एक पहिलं सर्कल कंप्लीट करतात, परत पुढचे, म्हणजे सेम पॅटर्नने डेव्हलप झालेलं. कॉलीफ्लॉवर मध्ये तुम्ही ते फुल डेव्हलप होतं ते कसं आहे? बाय युजिंग सम fractal geometrical concept. That fractal geometry concept also we have seen in the galaxy formation. That's why new Aryan 1 theory was developed by Calgary in 2009, and that is called as the fractal cosmological concept. Me and my group has worked on this fractal cosmology and published more than 15 to 20 papers. My two students were awarded with this topic. We have observed one paper on fractal cosmology at the time of 2010. And with the help of one paper, now my two students are awarded with the help of only one paper. See that? What is the power within that single paper? Because fractal cosmology is the new concept. They are introduced, and we have developed our different kinds of paper on that area also. Nowadays, F of QT is there. Means these theories. Why this theory is coming into the picture? Because of the alternative explanation for the cosmic acceleration. I talk about that under the Hubble telescope. We practically observe that universe is expanding with accelerated expansion form. Universe is expanding, but Einstein relativity is not able to explain that idea. Why it is expanding? That's why there is a role of modified theories. Second thing, directly, what is the nature of dark energy and dark matter? That was not explained by general relativity. Again, unification of quantum mechanics with general theory of relativity not given by the general relativity. All these modified theories of gravity, they try to accommodate all those ideas in their theories. Just now I talk about it. I am not going into the mathematical details about these three. Just now I talk about that. Three kinds of theories are there: curvature based, non-metricity based, as well as torsion based. What is the role of dark energy, cosmic structure for formation? Just now again I already talked about these concepts. It is not visible, so it's okay. So Einstein general relativity. See that. Just now first equation, d square is equal to g mu mu. This is very nice and beautiful equation which gives the solution of Einstein field equation. आता दिसताना आपल्याला mathematically complicated equation दिसतं, but which represent the idea of the solution of that next equation, g mu nu. This equation that was given by Einstein, and this is the solution of Einstein field equation, that is we call as the Riemannian metric. Riemannian metric means you know how to find out the distance, just Euclidean geometry, how to find out the distance between any two points by using the distance function by straight lines. कुठले दोन पॉइंट चा डिस्टन्स काढायचा असेल तर what is the idea? We just draw a straight line within that and find out the distance. But when we talk about the large distances, at that time that idea will not work. That will not suitable. That's why we need a basic such geometry which represent that curved geometry. And this is the formula d square is equal to g mu. That g mu is the fundamental tensor which play a very important role in the theory of general relativity. That fundamental tensor g mu will be constant, then that theory will tend to the Einstein Euclidean geometry. G mu is a function of xn, means function of variable. At that time that will represent the curved nature. म्हणजे तुम्ही geometry वाचता ना बघा, 1 dimension, 2 dimension, 3 dimension कसा बदलत जातो concept. 1 dimension linear line असते, y equals to mx plus c, linear equation. सेकंड ऑर्डर मध्ये 2 dimension मध्ये गेले तर काय जातं, सर्कल होतं, हायपरबोला, पॅराबोला, geometry बदल. पण त्याच पद्धतीने just like that the distance formula they were developed. Riemann developed the distance formula in such a way that basically they adopt both the geometries. When g mu will be constant, at that time that will be the Euclidean geometry. If it will be the function of some variable, it will represent the Riemannian geometry. Means curved nature more than 2 and more than 2 dimension. Means curved will be there. That's why this g mu introduced in this concept, and that field equation is completely depends on this g mu. This left side represent the geometry and right side represent the matter content. Okay, this lambda, again this lambda, see there is again a big story behind that lambda. Big story behind that lambda, that when Einstein introduced this lambda in his field equation, after some time he himself recognized that lambda will not useful, because he has also thought that the universe is not expanding, not contracting, that is as it is. Okay, and if it is expanding, to hold the universe, he has introduced that mathematical lambda there. Physically, to hold the universe, he has introduced that lambda notation. After some years, he was removed that lambda, and he said that it was blunder mistake in my life. Okay, but nowadays, see, म्हणजे काय होतं, 100 वर्षानंतर काय होतं, तेव्हा आइन्स्टाईन स्वतः त्यांनी काढून टाकलं. पण टुडे नाउ रिसर्च इज गोइंग अलॉंग द डायरेक्शन ऑफ दॅट लॅम्बा. आता काय होतंय की नाउ प्रॅक्टिकली ऑब्झर्व दॅट युनिवर्स इज एक्सपांडिंग. देयर इज अ बिग रोल ऑफ दिस लॅम्बा टू रिप्रेझेंटिंग द आयडिया ऑफ द डार्क एनर्जी अँड डार्क. दिस लॅम्बा रिप्रेझेंट द डार्क nature of dark energy and dark matter, and now this lambda is also many researchers taking as a function of T also, that relates with the time. Means Einstein think that it will not useful, but nowadays means when genius made mistake, that mistake will also having some good consequences. That is actually the practical reason nowadays research is going along the direction of that lambda also. Last 5 minutes. आता थोडं रिसर्च वर जाऊ आपण 5 मिनिट्स, कारण तुम्हाला ते समजणार नाही म्हणून मी जास्त त्याच्यापर्यंत गेलो नाही. Many ideas are not directly related with the many of you. Okay. So here we have considered epoch theory for our research purpose. Our research paper will start from here. Okay. With the help of first line element, just now I talk about the distance formula, line element, that will give the solution of Einstein field equation. This is equation number 1. It is a general equation. And last time I talked about the action, that Einstein used that action. With the help of action principle, they developed the Einstein field equation. And in epoch theory, see that in the equation 2, that in the action that T and F of T, that T and F of T are the replacement for that G mu function of Einstein, and mathematician developed the new theory that is called as the F of T theory of gravity. आता हे जे फील्ड इक्वेशन आहे, इक्वेशन नंबर 3. इक्वेशन नंबर 3 इज द रिप्लेसमेंट फॉर द आइन्स्टाइन फील्ड इक्वेशन ऑफ जनरल रिलेटिव्हिटी. मग ह्या इक्वेशनला घेऊन काय केलं पुढे? One part, geometrical part, this is the field equation. In this field equation, the matter part is the perfect fluid. We consider equation 3 and 4. After solving equation 3 and 4, we obtain these two equations, equation number 8 and equation number 9. These two field equations means these are the two differential equations. Non-linear differential equation, two equations having more than 5 unknowns. 5 unknowns, two equations. With mathematics, we know that if we want the exact solution, we need number of unknowns is equal to the number of equations. But here, the number of unknowns are more than the number of some assumption. That assumptions are physically suitable, viable for this solution. Then and then, that will practically give the solution. So first assumption is deceleration parameter. These are some parameters, Hubble parameter, deceleration parameter, again some mu, nu, omega. These are different cosmological parameters used for the study of the universe. This Q of T playing the role of how that universe work out. Means either universe is accelerating or decelerating. Acceleration म्हणजे काय? की continuously कार आपली पळते without slowing the speed. वाढतच चाललंय. Means speed is increasing, accelerating. आणि decelerating म्हणजे काय? Slow होत जाईल. म्हणजे contraction and expansion. That Q of T represent. Average scale factor means it is averagely along x, along y, along z, along three direction. What kind of expansion is going on? That representing by this physical parameter R of T. Mathematically, we have obtained this solution, that is equation number 40. With the help of solution, we first simple observation with the help of scalar factor. Either our model is in line with the present scenario or not. It is expanding. Why it is expanding? That we will check later on. Here, universe is accelerating and expanding with the help of this graph. We have detected basic information we have collected from this graph, and then we will go for the next observations. Here, see that initially we have calculated parameter in terms of time, and then we have converted all that parameters in terms of redshift. Why redshift? Because redshift gives the faster or exact and accurate practical solution, practical predictions of the universe as compared to the time parameter. That's why we have converted our model in terms of redshift. Means the light spectrum. Redshift म्हणजे काय असतं बघा? तुम्ही कधी-कधी पाऊस पडताना ते इंद्रधनुष वगैरे दिसतं ना, त्याच्यामध्ये तुम्हाला लाईटचा स्पेक्ट्रम दिसतो. लाईटच्या स्पेक्ट्रममध्ये 7 कलर्स आहेत. Means that light ray shifted towards the red end. That is called as the redshift. That is called as the gravitational shift. And that redshift we will use practically for observation of universe. हा data set बघा, आता त्याच्यात काय केलं आहे की before last 3-4 years before we have predicted many things theoretically without any base. But nowadays, with the help of some software, Python and all those, with the help of some software as well as some statistical techniques, we have fit our data with observational data set. Our model with the observational data set provided by some experimental evidences like lambda CDM model, supernova model. Means practically they have collected some data. That data set we have put here to predict the values of our unknowns. That unknowns in our solution. Mathematical differential equations solution लिहितो आपण. In that solution we have some unknowns are there. To predict the value of unknowns, we use some statistical techniques as well as some softwares, and comparison with the present data by Hubble parameter, Hubble telescope. That data we will fit with the help of data fit. See that here we have using some curve fittings. Curve fittings, here dots दिसतात ना, blue dot and red dots. आणि green line, red line, orange line, 3 lines are there. याच्यामध्ये lambda CDM model is the model that is the experimental model. They have observed some values, they have predicted something about the universe, and our model having some dotted lines, that dotted lines by using orange solid curves, and that base fit इथं बघा हे डॉटेड एका जागी कलेक्ट झाले दिसतात ना here एका जागी जे गॅदरिंग झालेले आहे त्याच्यावर म्हणजे काय our data is exactly fit with the that with the experimental data आणि मग ते कर्व फिटिंग झाल्यानंतर we have drawn the contour plots within these contour plots it is again a very difficult task to draw these contour plots as far as the predictions are there. 1 sigma interval, 2 sigma interval, these techniques are from statistics. 1 sigma technique given the 68% accuracy, 2 sigma technique given the more than 90% accuracy or confidence interval is there. आणि त्या accuracy वर again 3 sigma is there. 3 sigma म्हणजे हा जो contour plot आहे ना inside one contour plot, outside another contour plot. With the help of this contour plot, confidence interval goes to more than 95%. And some root mean square test, R square root mean square test. We use this formula with the help of data set. We fit our values by using the curve fitting. See that these are the values that we have fitted with the help of observational data set and some softwares and statistical techniques. If this R square value will 1 exactly 1, it is 100% match. If R square will be 1, it is 100% perfectly fit. And here see that our model gives the 92%. 92% means it is very very good as compared to the exact values with our predicted value. Means these are the help of this lambda CDM model and the standard Hubble parameter. This is the present rate of expansion H naught. It is the standard value presented by lambda CDM model and our value is 70.19 something. Means it is very close to the observational value. And with the help of these values, we have predicted many things about the universe. Deceleration parameter, transition phase is there. With the help of this technique, how that universe is expanding, what is there, many things are there. We in FOP theory we have used two models, one linear model and another is non-linear model or complex dynamics. With the help of two models, we predicted many things about the universe. The graphs and behavior about the density, about the pressure, and all these are the technical concepts. Okay. हा दिसताना बघा हा simple graph दिसतो, but it contains so many physical things. Means when z is equal to 0, at that time it will have some phase transition. If it has a phase transition and it has a value of 0.3, means it is in line with the standard lambda CDM model. Means our model, predicted model is in line with the observational model. And definitely when theoretical and observational both the concepts are agree with each other, then and then that will be universally accepted and then that paper or that research will be published in good journals. And that's why many small things we have observed, we try to curve fittings in such a way that our values will exactly match with the observational values. दिसताना सिंगल साधा ग्राफ दिसत असला तरी ह्या ग्राफच्या फिटिंग करण्यासाठी there is too much logic is there. All these are our observation and discussions, and with the help of we made some conclusions. And I am happy that my student is also here, Nitesh and Pramod. With the help of them, we have published this paper in very good Q1 journal of physics of the dark universe, having impact factor more than 6.5. So that's why our work, that again I am very happy and I say thanks to all the organizers to give the opportunity to present my work and talk all of you. Also I thanks to have a patience to listen all those things, because initially I thought that how I can explain all those theoretical part, because many of the students are sitting over there and after 1 hour it is very difficult to listen some theoretical concept, and many concepts are not directly familiar with you, but all of you sit and listen very patiently. So I again thanks to all of you, and with this keyword I stop here. Any kind of question please ask.
So first of all, thank you so much for delivering such a wonderful session. It was truly igniting. I have a query that in multi-universe concept, why precisely in multi-universe concept, why precisely we say that each particular universe is a bubble? Why we have considered that the precisely spherical shape and not any other?
See that if we observe the different models presented by different researchers, geocentric or heliocentric, initially they were assumption that the universe is circular. But now, when Kepler presented 3 laws for planetary motion, at that time Kepler identified that he used some fundamental mathematical equation, planetary equation of motion, and in that equation he solved that equation. At that time he observed that there are 2 kinds of models are there. One is circular, another is spherical. But circular model fails mathematically also. That's why we accept the spherical model of the universe. Means from long back, more than 2000 years, many mathematicians, physicists, astronomers observing all those things. And with the help of observation, with the help of telescope, with the help of mathematical formulas, now it is confirmed that our universe is in the shape of sphere, just like as a sphere.
In below the planets, if we see there is nothing. Einstein considered that there is a fabric and he named it as space-time fabric. You have explained that expansion and contraction both can lead to burst. What about that space-time fabric after these particular bursts?
Actually, after bursting, that universe is created. Big Bang is the theory. At that moment, that universe is created. Boost होने में क्या है? That will divided in different number of particles. That particle will create different galaxies, different kinds of matters, diagonal matter, dark energy, some protons. They by chemically they interact with each other. They will form the different kinds of matter. That is we call it as a universe.
So
First stage, seeds of galaxy. We call it as a seeds of galaxy created at the time of Big Bang. When Big Bang is happened, that is the creation of birth of the universe.
So each universe will have a different timeline, okay? Is it true?
Different timeline means different this gap in between the times. Many concepts see that. When we talk about the galaxies and study of galaxies and also concept of aliens, concept many times we talk about the aliens are there or not. See that under the Hubble telescope we have observed more than crores of galaxies are there. We are living in one galaxy, having our planetary system. Within that planetary system, one Earth is there. Within that one Earth, we are living there. And there are crores of galaxies are there. Means definitely in another galaxy, another planetary system may be there. Maybe another Earth is there. Within that Earth, maybe some human beings are there. And that is basic concept behind that aliens. Why we are not fitting with each other? Because nowadays, such kind of instrument or such kind of technological development is not there to travel some crores of kilometers in a single travel. That's why we or they will not meet with each other. That is actually my perception. Physically, different galaxies, long distances are there. That's why this kind of different universes, concept of multi-universes.
Thank you, sir.
Thank you, sir. Anyone else?
Any questions? मला नाही आलं तरी चालेल, विचारल्यानंतर जरा चांगलं वाटेल, काहीतरी बोलता येईल ना. एक तर काय असतं, काही समजलं नाही तर खूप जास्त समजलं असं होऊ शकतं. थँक्यू.
I request chairman of this technical session to kindly give the reflections on this keynote lecture.
Thank you, sir. Thank you, everyone. In concern with Einstein's theory of relativity, as we know, time is relative, and at present, time is related to our lunch break. So I conclude this session in very short words. Firstly, I am thankful to the organizing committee and convener of the conference, Dr. Ajit Yadav, sir, my friend, to giving me opportunity to share this session. Also, I am thankful to the guest lecturer or research person of this session, Professor Nyaneswar Pawar, sir. Presently, he is working as registrar, Swami Ramanand Tirth, Marathwada University, Nanded. He is given his lecture on dynamics of the universe. Firstly, I think I am from physics. Firstly, I think it was boring session because when we see toward the mathematics, the numbers, the formulas, the theorems, and etc., which are going above from our head. But he has given the lecture in dynamics of the universe. He is connected nicely the physics towards the mathematics. Or vice versa, he is connected the mathematics towards the physics. His work is completely applied in physics. As we know, the applications of physics are fulfilled with the mathematics. So, I am thankful to the Professor Nyaneswar Pawar, sir, for giving such a nice and informative lecture to us. On behalf of our organizing committee, I am thankful to him. And the session is over here.
Thank you, sir. With this, technical session 1 comes to successful conclusion. There is a half-hour lunch break is there at 2